Okay, my test. Is the sound clear? Please raise your hand. Okay, students. Okay, so today, if I'm not sure whether there's a noise or not, because I'm not at home. So currently, I'm free online, actually at Old Town Aeon in that. So hopefully, yeah, all the sound will be clear. Okay, if anything is not clear, please let me know. Alright, so today we're going to discuss our chapter 3 and chapter 4, form 4. Alright, okay, so we have a look first for this formula. Okay, as you can see in the formula list, for the gravitations chapter, the formula is give up to 9. So you have to very clear. You have to very clear about that formula is looking for what. Especially when you look at here, as you can see, we have one B here, another B here, and another B here. So if you're not sure what is real meanings for the formula, then definitely you can't solve the problems. Okay, so this is something that you have to alert. Okay, another one's question asked for this chapter. Right, so you have to be alert about the relationship. Okay, so you have to alert about the relationship. Okay, because whatever asked actually is not how to say, it's not important that you have to apply the formula, because basically the problem solving, you just need to substitute with the correct formula. Okay, and there were more questions on the asking about the relationship. So if you look at the last year questions, okay, example like this one. All right, so for the question 6, you see here, what is the factor that influence the escape velocity of the rocket so that it can be taken off from the surface of the Earth? So here, it's asking about the escape velocity. So once you clear about that formula, right? From the formula, this you can see which one is escape velocity. Is number 5, 7 of 9. Which one? 5, 6, 7, 5, 7 or 9? Next one, please. Which one is escape velocity? Right. So number 9 is escape velocity. So this is the one, escape velocity. Right. Okay. So once we have this, okay, square root of the 2 gm over r. Right. So here we know that escape velocity based on the formula. Okay, based on the formula, we have escape velocity equal to the square root of 2 gm over r. Alright. So when look at this, alright, so when you go back to formula, the m given here is a capital M. Alright, okay, it's a capital M here. So now, so we have the two mass here, mass of rocket and mass of the rocket and the Earth. Alright, so in this case, we only have one mass, so it doesn't have two mass. So when you say that the mass of the rocket and the Earth, so all these two masses here, so it means that this is a wrong answer. Okay, and the mass of the rockets, we KIV first. If you're not sure, we KIV first. But if you know that this is a capital M means that it's a mass of the Earth. So if you're sure for that, this is one also cancel. And then the distance of the objects from the center of the Earth. So, and compared to the other one distance, this is the distance of the object from the surface of the Earth. So there's a terms different here is the center of the Earth and the surface of the Earth. So here is the R. R is always referring to the center. to the center of the Earth. Remember, the distance r is center to center, right? Between the two objects, center to center. It's not based on the surface. So when once mentioned about surface, then the one will be wrong answer. So end up we have the answer C. Right. So this is how we solve this problem. Okay, the next one. Next one is also asking about the relationship. Which graph show the correct relationship between the gravitational acceleration to the distance out from the center of the Earth? So it's about the gravitational accelerations, G and the R. Then we go back to the formula. Is there any ones that we can find the G? So here, G and the R, this is the one. G equal to Gm over R squared. Alright. So in the case here, then come back here, we know that the G is already given here actually. The G is already given. So G equal to Gm over R squared. So this is a relationship. Okay, so in this case, so this one actually is deferring to a textbook straight away. So we only have this when the R equal to the R, right? Is equal to R here, then we will have the G is a max. So G is a max. So basically, all the max here is correct already. Then what we need to know is when the R is more than the radius of the Earth. So when we far away, when the object far away from the Earth, so the G will getting smaller and smaller. So basically, the one, okay, the relationship is the square, okay, because it's affected by the R squared. So once R more than the radius of the Earth, so the G prime here, right, it will be equal to the Gm over R plus R squared. So means that it will become curved line. So for the 3R, 2R, the curved line only one is the question, is the answer B. So the question is when the R is smaller than R here, why here is a straight line? Why is linearly proportional? Okay. This part for the last year assignment I already discussed. But the other classes I'm not sure, okay, whether you have learned about this or not, because actually it doesn't mention in the textbook. All right. Okay, when we go, okay, so we go back to the textbook first regarding the graph. There you go. So this one. Okay. So once we have the R bigger than the radius of the Earth, right? So it means that you can refer to this one. Right. So let's say when you stand on the Earth, right? So the distance will be the R. So at this moment, the position that you stand here, the gravity that you experience will equal to the Gm over R squared, which is this the moment that you have the maximum G. Okay. Once you far away from the Earth, so here's Earth. When you far away from the Earth, right, then your distance will be the R plus X. So it can become double R, triple R, and so on. So once this thing happens, then your G will equal to the Gm over X plus R squared. So because the Gm is a constant, no matter how far away from Earth, when your reference body is diverting to the Earth, so the Gm will be a constant value. Means your G will be inversely proportional to the X plus R squared. Right? Inversely proportional to the X plus R squared. According to chapter 1 relationship that we learned, when we have the graph showing the axis is an R, but the relationship is an R square, therefore it becomes the curve line. The relationship is become the curve line. So that's why we have the negative variance, because inversely proportional. Negative variance, then it's a curve line. This is proof that when your R is more than the radius of the Earth. But in the textbook, it is not explained. It's not explained anything about this. It's not explained about the G directly proportional, where you have the R less than the radius of the Earth. Right? So this is the missing part. Okay, then how are we going to understand about this? So if you study my module, basically you will know lah. Alright. So I already shared the module, my module before this. So anyway, I explain again. Okay, so let's say that is your original size of the Earth. Right. So at this moment, when you are standing on the Earth's surface, the G you experience will be the GM over R squared. Right. So which is this is a radius of the Earth, capital R. Okay. So once you are going to the closer toward the center, so let's say we have another small circle closer toward the. Okay. So now you go into the smaller size. So let's say now you are standing on this smaller size. Then now this is a small r, which is this small r actually is less than radius of the Earth. Right. Then what happens? Why the GM is no more constant, especially the M? Because now you are standing on the smaller M. This is a smaller M, right? And in the formula, what we have is a mass of the Earth. When you go toward the center of the Earth, you are standing on the smaller size of Earth. So the mass is not referring to the actual mass of the Earth. You are standing on the smaller mass. So now we're going to find what is the relationship for this smaller mass, or how we determine this smaller mass. Right? Okay. So to solve this problem, we have to make some simple assumption, which is a simple assumption is we assume that the density of the Earth is a constant, which is just only referring to the average density. So as what we know, density defined as a mass per volume. Right? So and the volume of the sphere, what's the formula? The volume of the sphere. What's the formula? Anyone tell me the volume of the sphere? How to find? Is that someone can tell me the volume of the sphere? Right. So okay, thank you, Vanessa. 4/3 by R cube. Right. 4/3 by R cube. Therefore, we change this one into the 4/3 by R cube. Right. So this is the volume. So when we have the bigger mass, so the mass will equal to the density multiplied volume. Is the moment that we have the density multiply 4/3 by R cube. Right. Which is this is the moment that we have the actual size of the mass. Which is the actual size of the Earth. Then the radius will be radius of the Earth. But once become the smaller Earth, which is we have the smaller R, then this smaller mass density is still the same, but the volume changed already. Now the volume become 4/3 by R cube, which is a smaller R. Okay, smaller R. Then 4. According to this, we substitute back to finding the G equal to the Gm. Now it's a smaller m over the smaller R square. So when substitute this mass into this formula, then we will have the G, okay, density 4 over 3 by R cubed over R squared. Then density 4 over 3 pi is a constant, includes the gravitational constant G. So all these are constant. G density 4 over 3 pi. Right? So all these are constant. And at the same time, we can simplify R squared and the R cubed become R. Then we have this G equal to the G density 4 over 3 pi R. Okay, and this is a constant. Then we can conclude that the G is directly proportional with the R. That's why when you have the R smaller than the radius of the Earth, so the relationship with the G is directly proportional. This is how we get straight line here. Okay, this is how we get this straight line. Okay, so here is the missing part. This is the missing part in the textbook. It doesn't have any explanation. Okay, so for this answer, so the answer B is the one here. Okay, and one more here. What is the following? Okay, so before that, is it okay regarding the graph? If yes, please raise up your hand. All right, okay, thank you. Okay, and next one. Okay, which of the following is a characteristic of the non-geostationary satellite? Okay, so this is also one of the highlighted positive that you still must study. Before I go through that, so since they want jump to the end part already, so let us go through again from the beginnings. Okay, so for this chapter 3, right? So first one, pretty sure you have to make sure that you understand, you're able to explain what is said by the Newton's universal law of gravitation. All right. So under this Newton, okay, law of gravitation here. So under this law, we have the two important statements here. Is the one. Because of these two important statements, therefore we have this formula to determine the gravitational force. Right. So M1, M2 over R squared. This is a relationship. Based on this relationship, so when they do the experiments, so when I think this one I have explained before, when we do the experiments, we only can determine the relationship. Okay, from the relationship, we know that whether it's directly proportional or inversely proportional. But the problem is when we want to make it become the formula, right? So this one, when we change the formula, means that we have the F R squared over M1 M2, it will equal to one constant value. So this constant value, whether it's equal to 1 or either equal to others value, we have to prove it by formula. Right? So especially when we plot the graph. If the graph showing that is this relationship prove that is with the origin 0, 0, means that this constant value it may not affect us. Right? So we do have any constant value. Maybe the constant value is only 1. But based on the relationship, they notice that one constant value, they call it as gravitational constant. So we determine through the experiment. Okay, and then how's the experiment design? So I already give the experiment design in my module, but in your in your label, you don't need to know so deep into that label, right? Just a knowledge for you. Okay, and then the gravitational constant here, okay, as given, okay, it will be given in the list of the formulas here, right? So let's okay, here, here, right. So it will give, yeah. I don't know why it put under the quantum physics. Okay, quantum physics. All right, it should give you the under the chapter 3, but somehow it seems like they make all the important constant value at the last part in the formula list. Okay, in the other part, it doesn't have any constant value. So maybe this year they were going to improve. They will put under one special category constant value. So they will list out all the constant value. Right. So somehow you have to be in that. Okay. So there's a constant value for the conditional constant, capital G. Capital G. All right. Okay. And this gravitational force, this force, this force is a force exists between two bodies. Force exists between two bodies. Right. So when you are given the two bodies, so there's the force exists between these two bodies towards each other. Okay, so here we have M1 is M2. And the distance between these two bodies is the R. Right? So the relationship is F equal to the G M1 M2 over R squared. And the force is a force exists between two bodies. So when you want to referring this force toward the one of the bodies, right? So you must know how to debate it with the formula. And recently there's a one question asked in teachers group. So far, no one has sworn yet about the answer. Maybe it's the time for I release it to you, see whether you can solve it or not. I think this morning or yesterday, they asked about these questions. Right. So these are questions. Let me highlight for you. Okay. So hold on. Let me print screen first. Right. So you are given the two planets P and Q, all right, with the different masses. So P have 2m, Q is a 3m with the distance x part. So now we have a rocket travel from the P to Q. Right, so now there's a rocket here. So here got a rocket. Right. So this rocket traveling from P to Q. So what is the distance of the rockets from the P to Q when the resultant gravitational force on it is 0? Right, so I know how to solve this question, but I haven't tried to solve it yet. Right, so why not try to solve it now? So you want to know where is the position of this rocket so that the resultant gravitational force is 0. Okay, try to solve it now. So once you're done, maybe you can share the answer. Working step. So maybe you just send into the group. I don't know about the answer yet because I haven't tried to solve. I already have the idea how to solve, but I haven't tried it. If you don't understand the question, maybe you can ask, okay, clarify, or ask for the hints. So the question looking for the rocket distance from the P, rocket from P. I give you the hints. You have to apply this formula. Because this is the one that you're looking for gravitational force between the two bodies. Anyone got the answers already? You may share your answer. I give you 3 minutes to try. Huh? Still solving. Right, 3 minutes over already. Anyone? No one can share answer. Seriously. Then how are you going to sit for exam? Anyone can share the answer? If you cannot solve at all, please raise your hand. I don't want to waste time. I see whether is there anyone. If you totally don't know how to solve, please raise your hand. So really do one try. All right, okay. Let's put down. Okay. So as I told you before, this is talking about the force exists between the two bodies. So now plus the rocket, now we have the three bodies. Right. So you can see as a three body. So it means that you can see as a rocket between the P. So here is a force exists between the rocket and the P. So this one considers a FP. Right. At the same time, we also have the other side. We have the force between the rocket and the Q. So this is one you can say that is a force Q. Okay. So where this is the force exists between the rocket and the planet. Okay. So in this case, right. So this question asking about the resultant gravitational force on the rocket is 0. So it means that rocket is the one our reference object. So once the rocket becomes the reference object, so we can see this as reference object. Then we are talking about what is the force pulled by the planet towards rocket. The word here is a FP. And then how much the force by the planet Q towards the rocket? It will be the FQ, right? So if you look at the FP, how to find FP? FP will equal to the G MP and the rocket mass over the distance between the rocket and the planet P. So we put as RP first, over RP squared. Right. And the force toward the planet Q, right, it will be the G MQ multiply the mass of the rocket and over the distance Q on the rocket toward the planet Q squared. Right. So to make sure that the resultant force equal to 0 means we have to make sure that, okay, FP is equal to the FQ because in vector they are opposite directions. Right. So P is a rocket towards planet Q. Q is a rocket towards planet Q, and the P is a rocket towards planet P. So to make sure that result is 0, so we have to make sure that these two are equal. So when we make sure these two are equal, so we have this one G MP mass over RP squared equal to the G MQ M over RQ squared. So from here we can simplify the calculation first. So G and G cancel. Mass of rocket cancel. Right? And now we will know that the MP is what? MP is a 2M. So MP is a 2M. MQ is a 3M. Right. So now we have the equations. 2M over distance P squared equal to the 3M over distance Q squared. So now just want to find the distance P. So we know that no matter how the rocket moves, no matter where its position, we know that the distance here, this distance of P, and this distance of Q, we know here our P plus our Q equal to X. So now I left it to you to solve it now. So I remind you the question asking about the distance P. Rocket from the planet P. So you're going to change everything to P. I do want to know about the Q. Right? So it means that you're going to substitute what is our Q. Our Q will equal to the X minus our P. So M and M here actually you can simplify it up. M and M here can simplify. So now only have this. I think you only can solve, right? So 2 over RP squared equal to the 3 over X minus RP squared. Okay. So remove the bracket or you switch it up. So we have the 2 X squared. This one minus. So we have the minus 2 X RP. Maybe we can do this some simple way. Okay, how to solve? Just use your calculator. I think you can get the answers. Right, so 3 divided by 3 over 2. So and we are not looking for X up, we're looking for RP. Sorry, yeah. So the RP will equal to the X over square root 3 over 2 plus 1. So 1 over 1.2. Sorry for the announcement. Okay. 1.225. So 1 over 1.225. So the answer is 0.816x. Right. So is that the answer given here? 0.816x. No answer. How come got no answer? Am I did anything wrong here? Let's see, no? Is it all of you get the same answer? Why got no answer here? 0.816. Maybe the answer option given is wrong. Right? So anyway, this is the one how we solve lah. Alright. So the idea here is understanding about the resultant gravitational force. Okay, it's the one that we determine in this way. So I think maybe because of that, until today there's no answer provided. All the option of the answer is wrong. So later after class I try again lah. So the solution method, I hope that you understand about the solutions method, and calculation to finish to get the final answer. So later I check, see whether there's any step that I did wrongly. Okay. Okay, so this is about the gravitational force between two bodies. And we do have a similar questions in my module. So if we refer to my module here, I give it to you before this. So this is the one you can try against for these questions, which is the calculation, the resultant gravitational force. Right. So this is a question that for you to try. Okay, because here there's a force between and between here. So here, right. So it's the one that you can try to do, similar with the question that we discussed just now. Right. Okay, so the next one. Okay, so here is all the substitution with the formula. Okay, and what else? So this one I already go through. So the next one, okay, just want to alert you about this one. Alert with the terms given. When you mention the term height, when talking about the height, it means upon the surface, on the surface of the planet. So when on the surface of the planet, make sure that you have to alert your formula substitution must be the R plus H, only you square it. Right. So you must alert about this. Okay, and next one. Okay, so about the effects on the low gravity and high gravity. So you can study some information already given in my module. Right. So this one I think is more for your knowledge. Okay. So I don't think so as in they will already ask lah. It's just for your knowledge to know. Okay. Which of the following this one for the satellite better will come here. Okay, and then the centripetal force. Okay, so centripetal force, right? Okay, back to the formulas here. Okay, you can see here the centripetal force is the one. Yeah, centripetal force. This and this, right? Because we know the F equal to ma from the chapter 2 yesterday, F equal to ma. So therefore the centripetal accelerations A equal to v squared over r. So that's why we have the m multiplied v squared over r. That's why you make this become centripetal force mv squared over r. So these two, okay, once you mention about the centripetal force or the centripetal acceleration, you must apply these two formulas. Okay, and why the A centripetal accelerations, okay, is v squared over r, right? So if you check the textbook, it was not mentioned at all. It's only straightaway introduced. Okay, centripetal accelerations equal to v squared over r. Alright, so it's not important for you to know why is equal to v squared over r. You just need to know, okay, and then make sure that in the formula list you understand about this, right? Okay, and it's used to calculations for to finding the linear speed, because from this formula, okay, from this formula, here we rearrange it, you will have the v squared equal to f r over m. Right, we rearrange the formula, you have this. Right, therefore you have the v equal to the square root of the f r over m. Right, f r over m, and the f is what? The f itself, okay, is the gravitation centripetal force or the gravitational force. You can substitute this back into the formula. So you have the square root of the g m m, okay, r over m R squared. So we substitute here, then the R and R we cancel. We left only R, M and M, small m cancel. So therefore we have the V equal to the square root of the GM over R, which is the linear speed here. Right, so this is how the formula that we can get from this one. Okay, when you substitute the force into here, actually you can get this linear speed equation. It's the one that we're looking use it to determine the linear speed of the satellite. Okay, linear speed of the satellite. So it's just one substitution of formula. Okay, so we can use this to finding the centripetal acceleration also. Alright. Okay. So this formula to determine the mass of the Earth or the mass of the Sun. Right. So why is only as a formula to determine the mass of the Earth and the mass of the Sun? Right. Because it referring to the satellite. Either is a man-made satellite or either is the natural satellite. Right. So just only rearrange the formula that we applied from the beginning. So you can referring to the module, right? So the module I gave you here, and all this you can skip. All this you can skip. So this is the one that how we get this formula to determine the mass of the Earth or either the mass of the Sun. Right? So because we have to referring to the concept of the circular orbit. Right? Circular orbit. Okay, another one's very important here when we're talking about the linear speed here. Right? So you have to know about another one is a 2 pi r over t. 2 pi r over t, this one. This is also the linear speed. This one also linear speed. But this linear speed is a specific use to determine the orbital period. Orbital period. So from here you can see this orbital period is affected by the R. Okay. So when from here we will know about the relationship. Right. So the concept here, if you're referring to the textbook, you need to know how's the periods with the periods or how's the linear speed when the radius is far away. Without increase, so you will have the definitely you will have the longer periods, right? But with the period, at the same time, actually because of the gravitational force or the centripetal force becomes smaller, then the linear speed will be slower. Right. So all this will have it will be asked according to the concept they understand about the man-made satellite later at the end of this chapter. Okay, about the Kepler's law. Okay, Kepler's law. Make sure that you clear about the Kepler's first, second, and third law. What's the difference? Right, what's the difference? So the Kepler's first law. I think the last year they don't really ask about the Kepler's law. Let's see. They don't really have the Kepler's law for the last year. So far in the paper 1 doesn't have. I think the paper 2 also don't have. So paper 2 about the centripetal force. Right? Centripetal force and also the it's everything about the centripetal force. Okay. So Kepler's law it doesn't have. So maybe you need to study more on this. Right? Okay. So I expecting that if they ask about chapter 3, so this year they may focus more on Kepler's law or they may focus more on the satellite. Right. So try to make sure that you're able to differentiate all the 3 laws here. Okay. And the formula. So here is we referring to formula. So this is the one that we get it from the Kepler's law. Right. T square and the R cube is directly proportional. This is one from the Kepler's law. T square R cube is directly proportional. So when we compare with two different cases, so we get this relationship. Right, T1 square over the R1 cube equal to T2 square over the R2 cube. Right, so it's directly proportional based on the Kepler's law, the law of periods. Right. So this is the one that I mentioned just now. When the satellite either is the natural satellite or either is a man-made satellite, when you have a bigger R or far away from the planet, so the periods will be longer. But the relationship is not directly proportional. The relationship is the T square is directly proportional with the R cube. Right? Remember about this relationship. Okay, it will help you to understand why the bigger R has the longest period. Okay, and next one. Okay, so okay, so this is the one. It only specifically used to determine the energy. Right. So this is for the determine the escape velocity. Right. Determine the escape velocity. So it's the next focus. We're talking about the satellite. Okay. On the man-made satellite, the important thing you need to know is about the escape velocity. Because this is the only one that we discuss here. Escape velocity here. So we have the original potential energy. So we have the negative because comparing to the kinetic energy, they are changed. So this coefficient potential energy change to kinetic energy. So it means it negative reduce in the energy, it will be showing the increase in the kinetic energy. So the total it becomes zero. That's why it make this conditional potential energy have a negative sign. Alright. So I think it mentions here. Where is it? So it is not mentioned here. Why you got a negative sign here? So it's just only have. So it's not mentioned. Only profit here. It's only profit here because the total becomes zero. So to make the difference zero, so we need to have a negative gravitational potential energy. We have to obey the principle of conservation of energy. Right? So we cannot create the energy, we can destroy the energy. So whatever that you have on the beginning, it will convert it as another one. And another one more thing that you learn from here is the mass of the rocket. It doesn't affect the escape velocity. The mass of the rocket, it doesn't affect the escape velocity. Right? So escape velocity is depends on the mass of the planet itself. Right? So comparing Earth and the Moon. Comparing Earth and the Moon, so the escape velocity that you need to escape from the Moon will be lower compared on the Earth because the Earth mass is much bigger than the Moon. Okay, but somehow you have to remember. Okay, even the formula it doesn't show that the mass of the rockets, okay, it will affect the escape velocity. But one thing you have to understand, the bigger the mass, you need to achieve the velocity, you need to have more fuel that you need to use, right? Because you still have to make sure that you can get the energy, kinetic energy, because the kinetic energy, the V inside here. So to have this kinetic energy, the mass will be affected. This mass will be the mass of the rocket itself, right? So let's say we have the two different size rockets. So both are going to escape from the Earth. The escape velocity is the same because escape velocity depends on the gravitational constant and depends on the mass of the Earth and also the radius of the Earth. Since that these two rockets is on Earth's surface, so it means that the G, M, and the R for the both rockets are the same. To get this escape velocity, then you need to give this much of kinetic energy with this escape velocity. So therefore, which one will be spend more energy? Then the bigger mass rocket will be spend more energy. So to have this more energy, then you have to give more okay, the source of energy, the fuel for the rocket. Right? So that's why it will affect about the launchings of the satellite. Okay, usually they were preferring to launching the smaller size satellite. Right, so because the costing will be much lower. So this is something that you need to know about the satellite. Okay, so have the two different types of satellite. Right, so we have the geostationary satellite and the non-geostationary satellite. So make sure that you clear the difference between these two use of the satellite. Right. Okay. So you can refer back to the mid-year and the trial question that I designed for you. So there is a lot of question, quite a number of questions that for the understanding about these two types of satellite. Okay, hopefully then you can apply that. Okay, so then the question here is see which of the following is the characteristic of the non-geo satellite. Okay, non-geostationary satellite here. So when you read, right? So the orbital period can be more or less than 24 hours. So this is correct one, right? Direction rotation is the same as the directions of the Earth's rotation. This for the non-geostationary satellite, it's not necessarily must be the same direction. So this one is wrong. Okay, and then used to communicate throughout the whole world, right? So communicate throughout the whole world here. So is this the correct one? So refer to the textbook here. Right, so used for the communications. Right, so used for communications actually is for the geostationary satellite. It's not for the non-geostationary satellite. Okay, so why it must be the geostationary satellite so that the signal is always there. So if the non-geostationary satellite, we have to waiting for when the signal will be come back. Right, so that's why this answer C is a wrong answer. Okay, and the position of the die is above the center. Is wrong, so that's why the answer is 1. Okay, and the next one. So, yeah, what is the gravitational force between the Earth and the Earth? So this one is a substitution formula, so nothing important to discuss. Okay, this is also give you the formula here. What about this experiment? Right, so you have to look at the formula provided here. Then after that, study about relationship. This is what I mentioned. From chapter 1, you have to learn based on the formula given you how you going to study the relationship. Like this one, I see the v squared against 1 over m. Okay, equal the gradients. So here then is the formula, right? For the v squared against 1 over m. So now when you rearrange it, so you have d equal to the mv squared. So talking about v squared, so mean the v squared is equal to the fd over m. So then you can study as a v squared equal to the fd multiply 1 over m. Then when you have the graph, this one is a y, this one is an x. So we will have the gradients of the graph is a fd. Okay, so we can use the gradients is equal to f. It's wrong, because the gradients should be equal to fd, not the f only. All right, and then the velocity of the stone increases as the mass of the stone increases. Right? So the velocity of the stone here is a v, the mass of the stone. So from here you can see the formula. When fd is constant, so when the mass increase, the v square will be decreased to remain the fd as a constant. Right, so that's why answer B is also wrong. Okay, the product of the f and d is always constant for the different mass of the stone. Okay, the product of the fd is always constant. Okay, because fd equal to mv squared. So when the mass change, so it will affect the v squared. Alright, so this one is talking about mass only, but it doesn't mention about the velocity. So maybe KIV first, we look at the answer B. As f increase, d increase. So f and d relationship, right? F and d relationship is the inversely proportional because there's a product. the product equal to mv squared. So it's right, answer B is wrong. So for me, the answer is should be C lah. Right? So always constant for the different mass of the sperm. Okay, but I'm not sure what is the answer given. So let me check the answer given. Okay, question 10. Question 10 answer C lah, right? So FD equal to mv squared. So FD is a variance, so it should be constant lah. For B. Right, so answer is C. Okay, I think that's all for chapter 3. Okay, and this one definitely you have to make sure that you're able to differentiate about these two types of satellite. Okay. So anything else you want to ask about chapter 3? Do you have anything you want to ask about chapter 3? So if you can proceed to chapter 4, please raise your hand. Yeah. Okay, chapter 4 actually is much easier compared to chapter 3. Chapter 3, a lot of students have worry because of the formula itself. Okay, as mentioned, there's no much thing that you need to know more about formula other than try to understand the relationship shown by the formula. And this one will be related to what you have learned from the chapter 1. Okay, and other than that, the substitutions, the problem solving for the calculation basically not really challenging in SPM level. But the question that I give you just now is definitely not going to ask SPM questions. So it will be just like a practice to make sure they understand about the formula. In SPM, there will be more directly substitute. I think you have to learn about the terms, especially what I mentioned about the height just now. Okay, so make sure that you understand about the how plus h. Okay, so for the chapter 4, okay, chapter 4 we can split into the two different parts. Alright, okay, which is the first part all about the heat energy. Alright, first part all about the heat energy is 4.1, 4.2, and 4.3. Second part is about the gas law. Alright, so 4.1, 2, and 3 get all about the heat energy. So I think that's something that you have to learn about these calibrations of thermometer. So last time they don't really focus on that, but I don't know why now the new one they have focusing on this calibrates of the liquid glass thermometer using the two fixed point. Right, so we do have the calculations on that based on the ratio. So as I mentioned before this, do not think this is something that you must memorize. This is not the equations. This one is not the equations. If you're referring to the equation provided in the exam, here this is only one. So here is about the heat energy as I mentioned just now. All these are about the heat energy. Right. So more importantly is about this one, Q equal to KT. Because when you have the immersion heater, there's a power supply to supply the heat energy. So with the power of the immersion heater multiply the heating time, so you will know how much the heat energy supply to heat up the substance. Right? And then this heat energy, we assuming that it's totally absorbed by the substance. There's no loss of energy to the surrounding. Okay, so these are assumptions so that we can make this PT equal to the ML, or we can make PT equal to the MC delta theta. So this one wrong again. It shouldn't be theta only, it should be the delta theta. Hopefully this year they change. Okay, because according to textbook is already made the corrections. Right, textbook is already made the correction for that formula delta theta. Right, so here textbook is already made the correction. Last time SPM they don't really make these corrections, right? Even in the textbook also theta is wrong. Okay, we're talking about the change of temperature. We're not talking about particular temperature. Okay, particular temperature, we're referring to the gas law. But for the heating process, involved for the specific heat capacity, we're talking about the change of temperature. So please be alert on this. Okay, and then the rest of three here, is a gas law. Okay, it's a 4.4. Okay, it's a gas law. So okay, so close it first. Okay. So for the 4.1, okay, other than the calibration of thermometer, later I will go through I will give you one example to try. So you need to understand what's meant by the thermal equilibriums, right? Thermal equilibriums. So there's three statements to understand about thermal equilibriums. First one, the temperature must be the same, right? So here, temperature must be the same between the two bodies in thermal contact. And when achieve the thermal equilibrium, so there will be no net heat transfer. Net heat transfer is zero. Net heat transfer is zero. Okay, and the rate of heat transfer is the same. Rate of heat transfer from the P to Q compared to Q to P is the same rate. When they are same rate, so there will be no more net heat transfer. Alright, so the temperature is the same. That is the understanding about the thermal equilibriums. Okay. So for the calibrations of the thermometer, so let's try about these questions. Calibration of thermometer, okay, actually the problem solving is based on the ratio concept as you learn in the mathematics, based on the ratio, right? The ratio of the temperature, change of temperature compared to ratio change of length, right? The ratio change of length towards the change of temperature and the change of length. Okay, please be alert. Okay, so let's try these questions. Let's say this thermometer. Actually, fast thermometer. Okay, so example, so determine the theta. What is the theta?
我放弃了，我只有30个，我
So once you have the answers already, please share your answer. Huh? Anyone got the answers already? Who got the answers already? Anyone got the answer? No one can share answer. So these questions definitely you cannot referring to that these questions given in the textbook. Alright, as I mentioned, this is not the equation that you should know. Alright, what you should know is about the ratio, the concept, the ratio change of length to the change of temperature. That's why when you referring to the list of formula, they will not include that formula at all. Alright. So to solve these questions, still no one can share answer. Anyone solve the questions already? Alright, so thanks for Ziwei the answer. Okay, 80 actually is correct answer lah. Right, so we have so many options to solve this problem. Right, as long as you referring to this one, change of length toward the change of temperature. Alright, okay, so compare the two different cases. Let's say if we want to take this 15 centimeter. This 15 centimeter is what? Actually is the theta minus negative 10. Right, or you can get this one as overall length here, 20. So it means that theta, you got the length 20 centimeter. Negative 10 degrees Celsius, you got the length 5 centimeter. At the 110 degrees Celsius, you got the length 25 centimeter. So this is only that the length referring to the particular temperature. But we want to solve, make sure that you find is a change. Alright. So now if we use the 20 minus 5, then what you have, it will be the theta minus negative 10. So which is here is equal to 15. Then this one will equal to the theta plus 10. Okay, the next one you can use 25 minus 5. Then you got 20. So 25 minus 5 is what? Is 110 degrees Celsius minus negative 10. Is equal to 120. So based on this, you got the 15 over 20 equal to the theta plus 10 over 120. Then your theta will equal to this one, 3 over 4. 3 over 4 multiply 120 minus 10. So you do it slowly one by one, right? So divided by 4, this one you got the 330, so it's a 90 minus 10. So you got answer 80 degrees Celsius. This is one of the options. If you don't want to use these options, based on the information that you get that they registered just now, so like this one, if you don't want to use these options, you can go through the other option, which is you can try. Let's say I want to use 25 minus 20. So I got a 25 minus 20. Okay, is 25 minus 20 is 110 minus theta. Then after that I got 5. Let's say 20 minus 5 also. Okay, 20 minus 5. Again, 20 minus 5 equal to the 15. Then 20 minus 5 is about the theta minus negative 10. So based on this one is equal to 5. So we have a 5 over 15 equal to 110 minus theta over theta plus 10. So if you do so, 1 over 3. So it means that you have the theta plus 10 equal to 110 minus theta multiply 3. Then you have the theta plus 10 equal to 330 minus 3 theta. Alright. Then you have the 4 theta equal to 320. So the theta 320 over 4 is still back to 80 degrees Celsius. So no matter how you do, right, it's still back to the same answer. So Okay, I hope that you learned about these questions. So now we see last year, is there any questions that related to the chapter 4? I think mostly you will be more focused on the gas law. Okay, so as you can see here, the decreasing of temperature will be caused, right? So this is about the kinetic theory of gases, right? So kinetic theory of gases here, the decreasing of temperature. So empty plastic bottle placed in the refrigerator and after a few minutes cooling the plastic bottle, then so air molecule distance decreases, right? So temperature of course the air molecule distance decreases, kinetic energy will increase, definitely is wrong. So this is the wrong answer. And the rate of condition within will increase also wrong. Okay, the number of molecule decrease also wrong. So that's why answer is there. Okay, because the distance become decrease, so that's why the volume reduce. Volume reduce, so that's why it will be 10 the bottle. Okay, and this is about the latent heat of fusion and latent heat the heat release during the solidifications. So this is a concept about the latent heat and also the heat release during the freezings or the they call it solidifications here. Right. So here is the understanding about the specific capacity and specific latent heat. Okay. So heat capacity, remember, it only happens. Heat capacity is only involved for the substance experience the change of temperature. How much energy need for substance to change the temperature. So make sure that you're able to differentiate between the heat capacity, with heat capacity, and also the specific heat capacity. When talking about specific, means that we're referring to the 1 kilogram heat capacity. Right. So the unit difference, heat capacity, the unit is only joule per degree Celsius. We're talking about heat capacity, the unit is only joule per degree Celsius. And now in the textbook, you given the symbol for heat capacity. Okay, let's see. Last time we don't introduce the symbol for heat capacity. So now in the textbook, introduce about the symbol. For me, it was very made the student confused because a specific heat capacity, the symbol is a small c. Right? Here you are, specific heat capacity is a heat capacity referring to the 1 kilogram. Right? With the symbol is a small c. So make sure that you be able to differentiate between these two. Right. So once there is involved the change of temperature, must be alert. Okay. So and latent heat, specific latent heat. So all these are already discussed before. So application data I come back. Okay. Then the specific latent heat. So for the latent heat, make sure that you understand there's a two type of latent heat. Right. There's a two type of latent heat. One is latent heat of fusion. Another one is latent heat of vaporization. Same also, we can have the term specific or without the term specific. Once we mention term specific, means that specific the mass differing is a 1 kilogram. If without the specific, means that it's a particular substance. Particular substance, how much is needs energy to make it change the on the state of the okay? Either it's from the liquid to solid, solid to liquid, liquid to gas, gas to liquid. Right. So when the question asks for the definition, make sure that you have the mentions from what change to what. Okay, instead of method for the substance. Right. But if without the specific mention about the fusions or vaporization, just a general, right? When using the general, just only have to say that during the change of phase. You don't need to specifically mention what is the change of phase or what to what. You don't need to mention unless it's a specific about the this fusion or vaporization. Then you have to mention it during the melting or during the freezing, right? So you have to mention the process, okay? So and then also about this heating curve and cooling curve, heating curve and cooling curve. Okay, so this one you learn the same thing in chemistry, right? So make sure you able to answer it. So I think the last year they got a question for this one, the cooling curve, right? So do not think that they always start on the gas. Right? You have to read the questions. Like this one last year, it's already mentioned. Is the cooling curve. Okay, it's a cooling curve for what? cooling curve for the metal in the liquid state. Liquid state. So it means that if on the beginning is liquid, on the beginning is a liquid here. So liquid then becomes the solid. Liquid becomes solid. Right. So here during the constant time here, constant temperature here will be the liquid plus solid. Right. So do not think always start from the gas. You have to read the question. As I mentioned many times already, take your time, read the questions carefully. Okay. So when there's an involved change of temperature like this one, Q to R. Q to R, there's no change of temperature. When it's no change of temperature, means it's a lantern heat. Others, R to S or the P to Q, there's a change of temperature. You see the temperature there. So R P to Q or R to S will be the heat capacity. Right? When there's no change of temperature, they want referring to the lantern heat. Okay, so all this explanation you have to make sure you learn, you read from the textbook. So this is nothing difficult, I think. Alright, so the data explanation is already given here. You can read here. So let's see what else. Alright, so I think that's all about this the first part for the related to the heat energies here. So now we come to applications here. Okay, so these two land space and the sea bridge. Okay, so okay, just read through again. So before this, exam already given before, so make sure that you're able to explain it. Okay, so the difference between the land base and the sea bridge. So now I just want to ask, get the concept. Okay, so to make sure the object not easily heat up, to make sure the object is not easily heat up, we're looking for the higher specific capacity or lower specific heat capacity. To make sure the substance is not easily heat up, we're looking for higher specific capacity or lower. Not easily heat up. Okay. When we're talking about not easily heat up or not easily cool down, also said, as long as referring to the change of temperature. If we don't want to make it easily change in temperature, so we're referring to the higher specific capacity. Repeat again, if the question related asks about something that is not easily make sure that it's not easily change in temperature, either getting easily get it up or not. So we're referring to the higher specific capacity, right? So to make sure there's no easily change in temperature. Okay. Because when you higher specific capacity, so you need more energy to make the change of temperature. All right. Okay. Another one thing that you have to remember, higher specific capacity make the substance not easily heat up. But it doesn't mean that it will make the substance absorb heat slowly. So these two concepts, they are not really related. Because when we study about the specific heat capacity, we just want to know how much energy needs to make the change of temperature. It doesn't relate to the thermal conductivity. So when the substance have a lower specific capacity, so it will make the substance easily heat up. But you cannot straight away comment it can easily heat up. It's because of that absorb heat faster, right? Or vice versa. Alright, so easily absorb the heat faster or slower, or easily absorb the heat or not. It depends on the thermal conductivity of the substance. Right? Depends on thermal conductivity. So thermal conductivity this is also included. There are many factors. For example, the surface area, or the surface area contact with the heat energy. Right, and also the colors. Right, so all these are the thermal conductivity. Right, so hopefully that you understand about this. Okay, and the next one is about the gas law. Gas law, nothing much I want to discuss. because the formula is clear already. You just need to make sure that you know which formula is related to which gas law. If you're referring to the formulas here, right? Referring to a formula here. So the PV, this one is a Boyle's law, right? So when the V over T, when there's a volume, so this one is a Charles law, right? And when they have a pressure here, there will be the Gay-Lussac's law, right? So still remember the answer that I shared before. Huh? Okay, we have the Gay-Lussac's law. Okay, please remember the names, the full names. Boyle's law, Charles law, Gay-Lussac's law. Yeah. Boyle's law, right? Make sure the spelling. And next one, the Charles law, right? Charles law. And the last one, Gay-Lussac's law. Right? Gay-Lussac's law. Please do not answer it as a gay law. Right? So I still remember they got the answer given during the Form 4 exam. I'm not sure whether I tell you something. The Form 4 exam, right? There's someone give me the gay law before. You see the spelling? Boyle's law, right? So one spelling is wrong, then the answer definitely is wrong. Okay. So I think there's a Form 4 square. See? It gives gay's law. I really don't know how to respond for this. All right. So please now, so don't forget it's a Gay-Lussac's law, no the gay law. Right? Yeah. So once you know about the latest law with some relationship they study, okay. So remember, in this case, especially about this one, especially when they involve the temperature here. When I explain the relationship, this temperature in your explanation, you must mention absolute temperature. So you cannot just say that a Charles law is that the volume and the temperature is directly proportional for the fixed mass of gas when the pressure is constant. You cannot just say that because directly proportional is not with the temperature. It's not the volume with the temperature. It's the volume with the absolute temperature. Volume with absolute temperature. So here, remember, this must be to the unit Kelvin. The unit Kelvins. Alright, so you must make the degree Celsius change to unit Kelvin. Right, with the plus 273. Right, so degree Celsius to Kelvin plus 273. Kelvin change back to degree Celsius minus 273. Right, so once you apply the formula, make sure that calculations of the temperature must be in unit Kelvin. And when the moment you get the final answers already, then only you change back to the degree Celsius. It's asking about the temperature. So let's see for the example questions. I think so. So here are the questions. Okay, just the envelope. So I think you still remember the trial exam. I think the questions higher percentage get wrong because of the temperature. You don't change it into unit Kelvin in calculations. So please alert about the calculations. Right. So what else I would remind you? Okay. So just like example you see here, it mentions this one. Right, directly proportional pressure, absolute temperature. Absolute temperature is really important. Okay. And then another ones, don't forget about the fixed mass of gas, also have mentioned. For fixed mass of gas at a constant volume. Right, so this for the Gay-Lussac's law, and then you also have to know how to explain about the Charles law and also the Boyle's law. Right. So I think that's all. Okay, for these two chapters. Okay, in case you have any question to ask about these two chapters, so after this, good night. So maybe you can focus on all the related questions that in the module or whatever question that you solved before this. So if anything want to clarify, you can send it to me. Right? So that with a specific focus chapter by chapter, I think will be easily for you to make sure that okay, anything that you understand for the chapter. Right? So there's a purpose that why I having this different slot, but a specific focus on different chapter to make sure that you know where is the important part that must make sure you master it. Okay, I think if not have any other questions, I think that's all for this slot. We'll see you later on the next slot. Okay, that's all. Thank you.
Thank you, teacher.